The universe is far stranger than it appears. Hidden within the massive new general catalogue of deep sky objects are secrets that rewrite the rules of reality. This journey reveals 25 of the most bizarre celestial objects ever recorded. You will see galaxies that cannibalize their neighbors, stars that die in impossible shapes, and structures that defy physics as we know it. How can a galaxy spin in two directions at once, and what carved a perfect keyhole into the fabric of a nebula? By the end, you will understand the cosmic forces that create true astronomical anomalies. What do you think is the universe's most beautiful mystery? Our first object reveals a cosmic predator in action. NGC 1316, also known as Fornax A, is a colossal lenticular galaxy that looks deeply unsettled. Its smooth outer disk is violently scarred by dark, chaotic dust lanes and faint, rippling shells of stars, like the ghostly echoes of a distant explosion. These are not the marks of a quiet life. They are the unmistakable fingerprints of galactic cannibalism. This giant galaxy is currently digesting a smaller spiral neighbor it consumed, its structure still reeling from the colossal collision. The evidence is everywhere. Astronomers see populations of globular clusters, those dense balls of ancient stars that move in all the wrong directions, clusters that once belonged to the victim galaxy and are now being dragged along as cosmic plunder. Even stranger, nestled within this old galaxy are pockets of surprisingly young, blue stars, stellar nurseries ignited by the immense shock waves and compressed gas of the merger. At the very heart of this devouring giant lies the engine of its radio fame, a supermassive black hole violently fed by the incoming torrent of matter. This feast powers two colossal jets that blast out into intergalactic space for millions of light years, creating the enormous radio lobes we call Fornax A. This object is not just a galaxy, it is a monument to destruction and assimilation, a cosmic beacon broadcasting the aftermath of a meal. But sometimes the cosmic meal is not yet finished. NGC 2623, catalogued as ARP 243, is a snapshot of a later, more intimate stage in this violent dance. What we see is no longer two distinct galaxies, but a single, wildly distorted object in its final, feverish act of merging. Its most stunning features are two immense tidal tails, colossal streams of stars and gas ripped out by gravitational forces, each stretching hundreds of thousands of light years into the darkness. They curve away from the chaotic central mass, forming a shape that looks unmistakably like a cosmic wishbone, a fragile structure of stellar debris on an impossible scale. These tails are the evidence of the incredible violence that has transpired, the fingerprints of gravity pulling and stretching the galaxies apart even as they combine. Yet the true drama is at the heart of this collision. The central region is a maelstrom of creation, a hyperactive starburst zone where the colossal clouds of gas from both galaxies have been violently compressed. This has ignited a firestorm of star formation, a flurry of hot, young, blue stars being born at a rate hundreds of times faster than in our own quiet Milky Way. It is a place of breathtaking contradiction, where destruction on a galactic scale directly fuels an explosion of new life. Astronomers study NGC 2623 as a living preview of a distant future. This is how many of the smooth, featureless elliptical galaxies we see in the universe are thought to be born. The majestic spiral arms of the two original galaxies are now gone, forever churned into this brilliant, turbulent core. The final act will see the long tidal tails slowly fade, their stars dispersing, while the central region settles into a swollen, ellipsoidal shape. Furthermore, all that incoming gas is not just making stars, it is also funneling a vast feast toward the supermassive black hole at the center, powering an engine that will one day shine brightly across the electromagnetic spectrum. This wishbone in the sky is not a symbol of luck, but a portrait of cosmic transformation, a temporary and beautiful state of pure chaotic change. The wishbone of NGC 2623 is a spectacular mess, but the universe has an even more famous portrait of galactic violence. NGC 4038 and NGC 4039, better known as the antennae galaxies, are a pair of colliding spirals caught in a breathtakingly slow cosmic dance. For over 100 million years, these two galaxies have been tearing each other apart, and we are seeing the climax of that process. Their name comes from the two immense, curving streams of stars and gas that have been flung far out into intergalactic space by immense tidal forces, forming delicate arcs that resemble the antennae of some colossal insect. These are not solid structures, but trails of stellar debris, the cosmic fingerprints of the immense gravitational pull each galaxy exerts on the other. At the center of this chaos, you can still make out the two distinct, bright cores of the original spiral galaxies, now locked in a final, irreversible gravitational embrace. They are circling each other, destined to merge completely into a single, giant elliptical galaxy in the distant future. But the real story of the antennae is not in the destruction, it is in the furious creation happening all throughout the collision zone. Where the vast clouds of gas from both galaxies slam together, they create immense shockwaves that compress the material to an incredible density. This triggers a firestorm of star birth, far more intense than anything seen in a normal galaxy. These are not just ordinary star clusters, they are superstar clusters, knots containing the mass of millions of suns packed into a region just a few light years across. These brilliant blue knots are some of the brightest and most massive stellar nurseries in our entire local universe, glowing fiercely with the light of countless newborn stars. This collision is writing the final chapter for both galaxies. The beautiful spiral arms are gone forever, shredded into these luminous arcs and clusters. All the available gas is being rapidly used up in this starburst frenzy, meaning that after this brilliant flash of new stars, the resulting merged galaxy will be a quiet, red, and aging place, populated by the long-lived stars born in this violent event. The antennae galaxies show us that even in the most destructive acts, the universe is fundamentally creative, forging new suns and solar systems from the wreckage of the old. The aftermath of a galactic collision can leave a system in a state of bizarre equilibrium. NGC 4650 is one of the most perfect examples of this, a galaxy that looks like a cosmic spinning top or a jeweled wheel set within another wheel. At its heart is a fairly normal lenticular galaxy, a bright football-shaped core of old yellow stars, but orbiting around this central body at a sharp 90-degree angle is a magnificent thin ring of gas, dust, and young blue stars. This is a polar ring galaxy, a structure so precisely perpendicular it defies our usual expectations of how a galaxy should be built. The formation of this cosmic oddity is a story of theft and gravity. The leading theory suggests that billions of years ago, the central galaxy had a close encounter with a smaller, gas-rich neighbor. Instead of a full merger, the larger galaxy essentially stripped away the smaller one's outer material, pulling vast streams of gas and stars into a wide orbit. But because of the specific angle of the encounter, this captured material did not settle into the existing plane. Instead, it was funneled into this extraordinary perpendicular ring where it has been orbiting ever since, slowly condensing to form new stars. What makes NGC 4650 so valuable to astronomers is the clear separation of its parts. The inner core and the outer ring rotate independently, like two separate cosmic clocks ticking in different directions. This gives scientists a unique three-dimensional view of the galaxy's gravitational field. By measuring how stars move in the core versus how gas moves in the ring, they can map the invisible scaffold holding the entire structure together, its dark matter halo. This strange, beautiful object is not just a celestial curiosity. It is a natural laboratory, allowing us to see the ghostly hand of dark matter shaping the visible universe from the inside out. While polar rings are delicate cosmic structures, some galactic mergers create a far more monstrous and enduring spectacle. NGC 5128, better known as Centaurus A, is the closest active galaxy to Earth and a titan of the southern sky. At first glance through a telescope, it appears as a bizarre hybrid, a classic smooth elliptical galaxy of old, red stars that has been violently slashed across its middle by a thick, dark, and ragged dust lane. This lane is not a simple band. It is a chaotic, knotty river of cold gas and dust, twisting and contorting as if caught in a furious cosmic wind. This dramatic appearance is the direct result of a colossal merger that occurred perhaps a billion years ago when a giant elliptical galaxy cannibalized a smaller, gas-rich spiral. The spiral stars were absorbed into the elliptical's halo, but its vast reservoir of gas and dust was not so easily digested. Instead, it was torn apart and sent into a turbulent orbit, creating that distinctive dark sash we see today, a fossilized remnant of a galaxy that no longer exists. But the visible galaxy is only the tip of the iceberg. Centaurus A is one of the brightest radio sources in our entire sky, earning its name as a powerful radio galaxy. This radio roar emanates from the very heart of the beast, a supermassive black hole weighing in at around 55 million times the mass of our Sun. This black hole is not dormant. It is actively feeding on the torrent of material from that ongoing merger. As matter spirals inward at incredible speeds, it heats up to millions of degrees and generates intense magnetic fields. Not all of this doomed material crosses the event horizon. Instead, some of it gets channeled and accelerated along the black hole's powerful magnetic field lines, blasted outward from its poles at nearly the speed of light. These are its relativistic jets, twin beams of ultra-energetic particles that punch straight through the galaxy and extend for over 1 million light-years into intergalactic space, far beyond the visible starlight. These jets are not silent. They scream across the radio spectrum, their synchrotron radiation created by electrons spiraling at near-light speed through magnetic fields. The implications of this extreme energy expulsion are profound. Where these jets plow into the tenuous gas that exists between galaxies, they create colossal, balloon-like structures called radio lobes which glow with invisible radio light. These lobes are cosmic pressure cookers, heating the intergalactic medium and seeding it with heavy elements and high-energy particles. They can even stifle star formation in their path by violently disrupting clouds of gas before they can collapse. Centaurus A serves as a nearby laboratory, showing us how the most violent engines in the universe, fueled by galactic collisions, can shape not just their own fate, but the environment for millions of light-years around them. Its dark dust lane is a scar from a past catastrophe, while its invisible radio jets are the ongoing echo of that violence, a whisper from a black hole that shapes the cosmos on a truly staggering scale. Centaurus A's dark sash is a scar from a single galactic meal, but some collisions create a far more chaotic and crowded crime scene. NGC 6240 is a cosmic monstrosity, a glowing tangle of dust and stars that looks less like a galaxy and more like a celestial explosion frozen in time. Its shape is violently irregular, with immense tidal tails and loops of stellar debris flung in all directions, the clear aftermath of not one but multiple galactic collisions. Astronomers believe this colossal wreck is the result of at least 3 smaller galaxies, or perhaps 2 large ones that each possessed a double core, all smashing together in a gravitational free-for-all. The chaos is not just on the outside. Deep within the brilliant, dusty heart of this merger, the true strangeness lurks. Using observations from space telescopes that can peer through the obscuring dust, scientists have discovered not 1 but 2, and possibly even 3, supermassive black holes all residing in the same central region. Each of these gravitational behemoths is the remnant core of a galaxy that once was, now brought together by the merger. They are currently orbiting one another in a tightening cosmic dance, separated by just a few thousand light years, which is practically spitting distance on a galactic scale. This makes NGC 6240 a unique and precious laboratory. We are witnessing the final stages before a multi-black hole merger, an event of almost unimaginable power. As these titans spiral inward, they violently stir the surrounding soup of gas and dust, creating shockwaves that trigger intense bursts of star formation and funnel vast amounts of material into their accretion disks. This is why the galaxy shines so brightly as an active galactic nucleus, its core glowing with the furious energy of not one, but multiple engines being fed at once. The eventual collision and merger of these black holes, which may happen in a few 100 million years, will send gravitational waves rippling through the fabric of spacetime itself, a testament to the violent birth of a single, even more massive black hole. This chaotic glow in the sky is a preview of a fundamental cosmic process, showing us how the universe's most powerful engines are forged in the crowded, violent mergers of entire galaxies. While colossal mergers reshape giant galaxies, the smallest stellar systems can also harbor explosive secrets. NGC 4449 is a small, chaotic dwarf galaxy that looks like a cosmic firecracker went off inside it. Its shape is wildly irregular, a ragged, glowing patch of stars and gas with no defined spiral arms or central bulge, resembling a miniature and even more turbulent version of our neighbor, the Large Magellanic Cloud. But this apparent disorganization is deceptive, for within its modest bounds rages a stellar frenzy. NGC 4449 is undergoing a starburst, forming new stars at a rate so intense it rivals much larger galaxies. The entire galaxy is dotted with brilliant blue knots, each one a massive cluster of hot, young stars born from the violent collapse of its abundant gas clouds. Pinkish-red regions of glowing hydrogen gas, excited by the fierce ultraviolet radiation from these newborns, stretch across the galaxy like cosmic scars, marking sites of intense stellar birth. This furious activity presents a profound mystery. Why is this tiny dwarf galaxy, which should be a quiet backwater of aging stars, burning through its fuel reserve with such reckless abandon? The answer likely lies in a recent close gravitational encounter. Astronomers suspect that NGC 4449 had a near miss or a minor merger with an even smaller companion galaxy or a massive cloud of dark matter. This interaction would have sent powerful shockwaves rippling through its gas, compressing it and igniting the galaxy-wide firestorm of star formation we see today. This identity crisis makes it a crucial object for study. It demonstrates that the dynamic processes which shape giants like the antennae galaxies are also at work on the smallest scales, proving that cosmic violence and creativity are universal, from the mightiest spirals to the humblest dwarfs. The furious starbursts in dwarf galaxies show creation on a local scale, but the most influential forces in a galaxy's life often work in silence. NGC 4697 appears at first glance to be the very picture of cosmic serenity. This elliptical galaxy is a smooth, featureless oval of ancient red stars, a quiet retirement community for suns that have burned for billions of years. There are no dramatic dust lanes, no brilliant blue nurseries, not even a hint of spiral structure. It is, by all visible accounts, a galaxy whose story is essentially over. Yet when astronomers pointed X-ray telescopes at this seemingly dormant giant, they saw something astonishing. The galaxy was not quiet at all, it was exhaling. Surrounding NGC 4697 is a vast, faint halo of superheated gas glowing fiercely in X-ray light. And emanating from the galaxy's core are immense plumes and bubbles of this million-degree material, being driven outward into the surrounding void. This is the work of a supermassive black hole at the galaxy's heart, not in a dramatic feeding frenzy, but in a state of controlled, powerful respiration. The process is a masterclass in cosmic feedback. As some gas in the galaxy slowly cools and falls inward, it eventually reaches the black hole's accretion disk. The immense gravitational energy released does not all vanish into the event horizon. Instead, a portion of that energy is converted into powerful winds and jets that blast back outwards, reheating the surrounding gas and pushing it away. Think of it not as an explosion, but as a cosmic windmill where the inward trickle of material powers an outward gale. This black hole wind serves a crucial regulatory purpose. By expelling this vast reservoir of hot gas, the black hole is essentially removing the fuel for future star formation. It prevents the galaxy from cooling down too much and igniting another burst of stellar birth. This elegant feedback loop explains why giant elliptical galaxies like NGC 4697 are so red and dead, filled with old stars and little new activity. The central black hole, through these gentle but persistent outflows, has put a cap on its own galaxy's growth. It is a remarkable revelation. The most dominant object in a galaxy, often seen only as a destructive force, also acts as a cosmic governor, maintaining equilibrium and shaping the galaxy's long-term evolution by simply breathing fire into the void. The quiet governance of a black hole's breath shapes a galaxy over eons, but sometimes the universe leaves a more immediate and violent signature in the stars themselves. Just beyond the famous cosmic gathering known as Stephan's Quintet lies a solitary spiral that holds a secret of its own. NGC 7331 is often called the twin of the Milky Way, a grand design spiral of similar size and majesty, with elegant arms dusted with pink stellar nurseries and wrapped around a bright yellowish core. From a distance, it is a portrait of galactic normalcy, a familiar island universe, but looks are deceiving. When astronomers began to measure the motion of its stars and gas, they found something deeply unsettling. The inner region of the galaxy, the bright bulge surrounding the core, is spinning in one direction, yet the vast outer disk, the beautiful spiral arms themselves, are rotating in the opposite direction. It is as if the heart of the galaxy and its body are engaged in a silent, slow-motion tug of war. This phenomenon, known as counter-rotation, is a dynamic puzzle that shatters the simple model of a galaxy spinning like a rigid plate. Such a profound disconnect does not happen by accident. The leading explanation is a story of galactic cannibalism on a modest scale. Billions of years ago, NGC 7331 likely had a close encounter with a smaller, gas-rich companion galaxy. This dwarf galaxy would have been orbiting in the opposite direction relative to the larger spiral's rotation. As the two drew near, the immense gravity of NGC 7331 began to tear the smaller galaxy apart, slowly pulling its stars and, crucially, its vast reservoirs of gas into its own orbit. Because this captured material was moving backwards, it did not simply blend in. Instead, it settled into the inner regions, creating a separate, counter-rotating disk within the larger galaxy. Over time, this stolen gas fueled new generations of stars that inherited its backward motion, locking the contradiction into the galaxy's very structure. Studying this celestial twin is a gift for astrophysicists, but it also complicates their work enormously. Galactic models that assume a simple, unified rotation fail spectacularly when applied to NGC 7331. Its existence forces scientists to account for the messy, chaotic history of mergers, large and small, that are woven into the life story of every galaxy. It proves that even a galaxy that looks perfectly normal, a mirror of our own Milky Way, can harbor a violent past written in the contradictory motions of its stars. This beautiful spiral is not just a twin, it is a reminder that the quietest-looking places in the cosmos often hold the loudest secrets. The contradictory spin of NGC 7331 reveals a galaxy's hidden history, but sometimes the cosmos carves its secrets directly into the light. NGC 1999 is a different kind of celestial mystery, a glowing cloud of gas and dust known as a reflection nebula located near the famed Orion Nebula. Unlike the violent collisions of galaxies, this object is a stellar nursery, a quiet chamber where new stars are being born. Its ethereal blue glow is not its own light, but starlight from a brilliant newborn star called V380 Orionis, scattering off the surrounding dust like a cosmic flashlight in a fog. Yet at the very heart of this beautiful blue haze, there is a profound and unsettling emptiness. A perfectly dark, keyhole-shaped void stares back at us, a patch of absolute blackness set against the radiant glow. For decades, astronomers had a simple and elegant explanation for this dark keyhole. They believed it was a Bok globule, an incredibly dense, cold cloud of gas and dust so thick that it completely blocks the light from behind it. It would be like seeing a silhouette cut out of a luminous curtain. This theory fit perfectly with what we knew about star-forming regions, but then the powerful infrared eyes of the Herschel Space Observatory looked directly at this dark patch, expecting to see the faint heat signature of that cold, obscuring dust. To the astonishment of the scientific community, they saw nothing. The keyhole was not a dense cloud, it was a genuine hole, an empty cavity punched right through the fabric of the nebula. The background sky, usually hidden, was visible right through it. This was not an absence of light, it was an absence of stuff. The question then became not what was blocking the light, but what incredible force could have excavated such a perfect void. The answer lies in the furious energy of the very young stars being born in this chaotic region. The leading theory points to the violent outflows from infant suns. As a protostar forms, it can unleash powerful bipolar jets, tightly focused beams of material screaming away from its poles at hundreds of kilometers per second. These jets act like cosmic blowtorches, plowing through the surrounding nebula material and blasting it away. Alternatively, the intense stellar winds and radiation pressure from a massive newborn star could have created a powerful shockwave that swept the area clean, like a celestial broom pushing dust and gas to the sides and leaving a cleared path behind. The keyhole shape itself is a fossil of this process, a tunnel or a bubble carved by these focused outflows, giving us a three-dimensional view into the structure of the nebula. This empty space is therefore a testament to the incredible power of stellar birth. The same forces that gather material to create a star are also violently destructive, sculpting their surroundings and creating bizarre, empty monuments like this cosmic keyhole. It is a stunning reminder that even in the act of creation, the universe leaves behind signatures of immense power, etching its history not in stone but in shadow and void. The keyhole of NGC 1999 is a void sculpted by stellar birth, but the death of a star can carve structures of even more breathtaking complexity. NGC 6302, known as the Butterfly Nebula, is a celestial spectacle of furious finality. Located in the constellation Scorpius, this planetary nebula is the expelled outer atmosphere of a dying sun-like star, now illuminated by the intense ultraviolet radiation from its exposed, searing hot core. What makes it extraordinary is its shape, two vast, symmetrical wings of glowing gas, each spanning over 2 light years, that resemble a cosmic butterfly in mid-flight or the exhaust plumes of a titanic twin-engine jet. This intricate bipolar structure is not a gentle unfurling, but the result of a violent and constrained death. At the very heart of this beautiful chaos lies one of the hottest stars ever discovered, a white dwarf with a surface temperature exceeding 200,000 degrees Celsius. Yet for all its ferocious brilliance, we cannot see this stellar ember directly. It is hidden from view, shrouded by a massive, dense, and cold equatorial ring of dust and molecules, a thick cosmic belt. This dusty torus acts as a celestial corset, forcing the star's final, powerful outflows to escape only through the poles. Imagine a balloon squeezed tightly around its middle. The air rushes out forcefully from the top and bottom. In the case of the Butterfly Nebula, the dying star's sporadic, super-speed stellar winds blasting outward at millions of kilometers per hour are funneled into these polar channels. As these high-speed winds slam into the slower-moving material ejected in earlier phases of the star's death throes, they sculpt the gas into those intricate, wing-like lobes and create the delicate, filamentary structures visible within them. The angular, almost mechanical appearance of the wings is a direct fossil of this dynamic process, a snapshot of physics in extreme action. This beautiful nebula is therefore a cosmic paradox, a structure of immense delicacy born from constraint and violence, a final, glorious testament to a star that chose to die not with a whimper, but within the focused fury of a polar gale. The delicate wings of the Butterfly Nebula show a star's final breath channeled by dust, but the universe can craft death in far more explosive and intricate geometries. NGC 7027 is a cosmic jewelry box, a young and astonishingly dense planetary nebula that gleams with a harsh, rectangular light. Its shape is not a soft sphere or elegant wings, but a sharply defined, almost box-like structure, layered like a nested set of glowing shells. This is the aftermath of a stellar explosion that happened in the blink of a cosmic eye. While most planetary nebulae take tens of thousands of years to form, the central star of NGC 7027 blasted off its outer envelope in a sudden, violent paroxysm, an event that may have lasted only a few decades. We are seeing the shockwave from that catastrophic event still plowing through space, illuminating and sculpting the debris into these crisp, geometric forms. The nebula is not just a hollow bubble. It is packed with an unusually high density of molecular gas and dust, a thick and chaotic environment more typical of a stellar nursery than a stellar graveyard. Within this violent, irradiated maelstrom, astronomers have made a bizarre chemical discovery. They have detected the clear signature of large, complex organic molecules known as polycyclic aromatic hydrocarbons, or PAH. These are essentially soot, the same kind of carbon-based compounds found in car exhaust or charcoal grills. Finding them here is profoundly strange. The central star is a searing ultraviolet furnace, and such intense radiation should tear these delicate carbon rings apart almost instantly. Their survival suggests the nebula is a place of incredible contrasts, with pockets of surprisingly cool, shielded dust where complex chemistry can stubbornly persist right next to zones of apocalyptic energy. This makes NGC 7027 a unique chemical laboratory, a place where the building blocks of soot and perhaps even more complex probiotic molecules are being forged in the extreme environment of a dying sun. It is a beautiful, box-shaped paradox, proving that even in the most violent stellar deaths, the universe is quietly, stubbornly assembling the intricate pieces of potential new beginnings. Far from the violent deaths of stars, a different kind of wanderer moves through the galactic night. NGC 2419 appears in telescopes as a faint, fuzzy smudge in the constellation Lynx, easily mistaken for a distant galaxy. But it is something else entirely, a dense sphere of ancient stars known as a globular cluster. What makes it extraordinary is not its composition, but its location. This cluster resides a staggering 300,000 light-years from the center of the Milky Way, far beyond the luminous spiral of our galaxy's disk and even far outside the vast, diffuse halo of dark matter that surrounds it. To put that distance in perspective, if our entire galaxy were the size of a dinner plate, most of its stars would be within the china, but NGC 2419 would be a lone grain of sand sitting on the table over a foot away. This immense isolation has earned it a dramatic nickname, the intergalactic traveler. Its motion tells an even stranger story. Unlike the hundreds of other globular clusters that orbit the Milky Way with relative haste, this wanderer moves with a languid, almost reluctant speed. Its orbit is not a tight loop, but a vast, slow ellipse that takes an estimated 3 billion years to complete, one of the longest orbital periods of any object bound to our galaxy. This sluggish pace and its incredible distance raise a profound question. Does this cluster truly belong to us? Astronomers suspect it may not be a native-born satellite of the Milky Way at all. One compelling theory is that NGC 2419 is a cosmic castaway, the remnant core of a dwarf galaxy that was torn apart by the Milky Way's gravity billions of years ago. In this scenario, all the dwarf's outer stars were stripped away and scattered, leaving only its dense, resilient heart to continue its lonely journey. Another, even more intriguing possibility is that this cluster is not captured, but is merely a temporary guest. Its slow speed and immense orbit suggest it might have enough energy to eventually escape our galaxy's gravitational grip altogether. It could be a true intergalactic wanderer, a celestial nomad that originated in the void between galaxies and is now just passing through our corner of the universe, destined to drift back into the endless dark. Studying its precise chemical makeup offers clues. The cluster's stars contain different ratios of heavy elements compared to most Milky Way globulars, hinting at a separate origin story, forged in a different stellar nursery long ago and far away. This faint smudge of light is therefore a gravitational mystery, a celestial question mark. It forces us to reconsider what it means to be part of a galaxy, reminding us that the borders of our cosmic home are not sharp lines, but fuzzy realms where captured wanderers and fleeting visitors silently trace paths written by the deepest forces of the universe. While some wanderers drift in isolation, others rule from the very center of cosmic crowds. At the heart of the immense Coma cluster, a sprawling metropolis of over 1,000 galaxies, sits a true gravitational monarch, NGC 4874. This is not just a galaxy, it is a supergiant elliptical, a cosmic leviathan that makes even the Milky Way look like a modest village. Its smooth, golden yellow glow spans over 10 times the diameter of our own galaxy, a vast sphere of ancient stars held in the grip of incomprehensible gravity. But the true measure of its dominance is not in its starlight, but in the incredible retinue that surrounds it. Swirling around this titan is a halo of such staggering richness it defies belief. Orbiting NGC 4874 are not just billions of stars, but hundreds of thousands of globular clusters. Each of these dense, spherical star cities contains up to 1 million ancient suns. To put that in perspective, our entire Milky Way possesses only about 150 of these clusters. This galaxy is adorned with a glittering swarm of them, a cloud of stolen jewels on a scale that is almost impossible to comprehend. Where did this incredible wealth come from? This is the legacy of a cosmic emperor with a voracious appetite. Over billions of years, NGC 4874 has used its overwhelming gravitational pull, anchored by a supermassive black hole billions of times the mass of our Sun, to cannibalize countless smaller galaxies that drifted too close within the dense cluster. Each devoured galaxy contributed its stars to the giant's glowing body, but its resilient globular clusters, the dense cores of those galaxies, were not so easily digested. Instead, they were stripped away and added to the swirling halo, trophies of a long history of conquest. This makes the halo a fossil record of the cluster's violent evolution. But NGC 4874 does not just dominate through gravity alone. It actively shapes the environment of the entire Coma cluster. At its core rages an active galactic nucleus, a supermassive black hole being fed by the constant inflow of gas from its surroundings. This engine pumps out tremendous energy, heating the superhot plasma that fills the space between the cluster's galaxies. This black hole feedback acts as a cosmic thermostat, preventing the gas from cooling too quickly and collapsing to form new stars, thereby regulating the growth of every other galaxy in the neighborhood. This supergiant is the anchor and the engineer of its entire realm, a gravitational trap that consumes its neighbors and a radiant heart whose energy dictates the climate for millions of light years around it. From the gravitational throne of a supergiant, we turn to a galaxy that writes its secrets in light. NGC 1097 is a stunning barred spiral, its long, luminous central bar acting as a cosmic highway, funneling gas and dust toward a ravenous heart. But what truly sets this galaxy apart is not its grand design, but the ghostly signature at its very core. When astronomers observe it through filters sensitive to the red glow of hydrogen alpha light, they see something astonishing: two faint, opposing jets of material projecting directly from the nucleus, forming a distinct and mysterious X shape across the galaxy's bright center. These are not the colossal million-light-year radio jets of a Centaurus A. These are delicate optical filaments, a rare and subtle phenomenon that offers a direct window into the final moments before matter vanishes forever. The leading explanation is as elegant as it is violent. The galaxy's prominent bar efficiently channels vast streams of gas inward, feeding the supermassive black hole that resides at its nucleus. As this material spirals in at near light speeds, it forms a searing, flattened accretion disk. But not all of this doomed matter finds a straight path into the abyss. Intense magnetic fields and ferocious collisions within the disk can launch some of the inflowing material back out, not along the poles, but along the plane of the disk itself. Think of it as a cosmic overflow valve, a spray of material ejected sideways from the chaotic whirlpool just outside the event horizon. This ejected material, glowing with the characteristic red light of excited hydrogen, traces the faint lines of the X, marking the interface where inflow becomes outflow. The rarity of these optical jets makes them a precious clue. They suggest a specific, perhaps transient, state of feeding, a black hole dining with such ferocity that it cannot consume everything neatly, spitting some of its meal back out in a visible sigh. This X is therefore a real-time diagram of extreme physics, a signature of the complex dance between gravity, magnetism, and angular momentum that plays out in the darkness just beyond the point of no return. Its spherical perfection hides a turbulent secret. NGC 4552, better known as Messier 89, is a galaxy that appears almost too perfect. Nestled within the sprawling Virgo cluster, it is an elliptical galaxy, but unlike the stretched, football-shaped ellipticals common throughout the universe, M89 is a near-perfect sphere. From our vantage point, it presents a smooth, featureless orb of ancient yellow stars, a cosmic marble of serene symmetry that seems to defy the usual chaotic dynamics of galactic life. This flawless shape suggests a quiet, undisturbed history, a system that settled into a state of relaxed equilibrium billions of years ago. But the universe rarely creates such perfection without a story, and M89's story is written in invisible ink. When astronomers pointed X-ray telescopes at this celestial sphere, they saw something that shattered the illusion of calm. Surrounding the galaxy is an immense, faint envelope of superheated gas, a halo stretching over 150,000 light-years into the void. This gas glows not with starlight, but with the fierce energy of X-rays, betraying temperatures of millions of degrees. Such a vast, hot atmosphere is not typical for an elliptical galaxy of this size. It is a clue, a thermal signature of past violence. Furthermore, deep optical images reveal even more subtle evidence: faint, concentric shells of stars embedded within the galaxy's outer halo. These are not random features, they are the gravitational echoes of a catastrophic event. Like ripples frozen in a pond, these stellar shells are the unmistakable fingerprints of a galactic merger. The leading theory is that, perhaps a billion years ago, M89 cannibalized a smaller, gas-rich companion galaxy. the process would have been violently disruptive, sending powerful shockwaves through M89's own gas and distorting the orbits of its outermost stars. Over immense stretches of time, gravity has smoothed the galaxy's visible body back into this perfect sphere, a process called violent relaxation. But the evidence persists in these faint outer structures and in that immense, lingering halo of hot gas, which was likely heated to its extreme temperatures during the merger's chaotic climax. This makes M89 a profound lesson in cosmic archaeology. Its serene, spherical facade is a masterpiece of gravitational restoration, a calm surface over deep and turbulent waters. It teaches us that a galaxy's present appearance can be a beautiful mask, hiding a dramatic history of collision and assimilation written in the faint light of exiled stars and the searing breath of trapped gas. This spherical perfection is a cosmic illusion, a mask over a violent past. Yet some galaxies wear their chaos openly, their structures torn and reshaped by recent catastrophe. NGC 428 is one of these cosmic survivors, a spiral galaxy caught in a state of beautiful disarray. It should be a grand, orderly pinwheel, but its form is anything but serene. Its spiral arms are not graceful, sweeping arcs. They are broken, patchy, and wildly asymmetric, twisting in chaotic loops that give the entire galaxy a ragged, almost shredded appearance. This turbulent look is more typical of small, irregular Magellanic Cloud-type galaxies, not a large spiral like this one. The reason for this profound disturbance is written in the scattered, brilliant blue knots that dot its disk like flashbulbs going off at a crime scene. These are sites of intense, sporadic star formation, stellar nurseries ignited not by the gentle rhythms of a quiet galaxy, but by immense shockwaves. The leading theory points to a recent, violent encounter. NGC 428 likely experienced a close gravitational dance with a smaller companion galaxy, or perhaps even a full merger with a gas-rich dwarf. This interaction would have sent powerful tidal forces rippling through the larger spiral, violently stirring its vast reservoirs of gas and dust. Imagine throwing a stone into a still pond. The resulting waves disrupt the smooth surface. On a galactic scale, a tidal interaction is that stone, and the spiral arms are the water, now churned into chaotic, overlapping ripples. This gravitational trauma compressed giant clouds of gas, triggering bursts of star formation not just in the arms but scattered randomly across the entire disk. The galaxy's structure is now a fossil of that encounter, its once orderly rotation disrupted, its shape still settling from the cosmic collision. NGC 428 is a galaxy caught in the act of healing, a testament to how even a major spiral can be violently remade by the gravitational pull of a passing neighbor, its beauty now lying in its glorious star-forming turmoil. The chaotic healing of NGC 428 shows a galaxy recovering from a blow, but some collisions are still in their violent opening act. NGC 2207 and IC 2163 are a pair of grand spiral galaxies caught in the moment of a glancing, yet devastating cosmic punch. From our distant vantage, they look like two celestial whirlpools locked in a slow-motion impact, their outer arms already violently entangled. The larger galaxy, NGC 2207, is not merely passing by, it is actively dismantling its smaller companion. You can see the evidence in the profound distortions. IC 2163, the galaxy on the right, is being stretched and pulled into a wildly elongated shape. Its once symmetrical spiral arms now deformed into a long, luminous tidal tail that streams away from the impact zone, a river of stolen stars and gas. This is tidal stripping in its most dramatic form, a gravitational robbery happening in real time across 100,000 light-years. The force of this interaction does more than just tear material away, it compresses the very fabric of the galaxies. As the two immense gravitational fields sweep past each other, they generate colossal spiral density ripples that move through the galactic disks like tsunamis through an ocean. Where these waves pass, they squeeze the vast, diffuse clouds of interstellar gas to incredible densities. This rapid compression is the ultimate trigger for star birth. Throughout the overlapping regions of the galaxies, and especially along the distorted arms of IC 2163, brilliant blue knots ignite. These are superstar clusters, stellar nurseries containing the mass of millions of suns, blazing to life because of the violence. The system glows with the light of this induced starburst, a firestorm lit by the collision itself. This pair is a living textbook of galactic dynamics. We are witnessing the precise mechanisms that can transform two majestic spirals over billions of years into a single, messy elliptical galaxy. The stream of material between them is a direct pipeline, feeding the larger galaxy with fuel for future generations of stars while starving the smaller one. The intense star formation is a brilliant but fleeting flash. Such furious burning will consume the available gas relatively quickly, leaving behind a population of aging stars. For now, NGC 2207 and IC 2163 offer a snapshot of beautiful, destructive creation, a cosmic dance where gravity writes the steps in spirals of light and rivers of stolen suns. While galactic collisions reshape the cosmos in spectacular ways, other systems offer a quieter, more reflective kind of mystery. NGC 6744 is a portrait of what our own Milky Way might look like if viewed from a distant vantage point. This is a grand design spiral of breathtaking scale, a near-perfect twin in structure, but one that is significantly larger and more majestic than our home galaxy. Its bright central bulge, threaded with a distinct bar, gives way to sweeping, luminous arms that are dusted with the telltale pink glow of stellar nurseries and dark, intricate lanes of cosmic dust. The resemblance is uncanny, yet the differences are profound. The spiral arms of NGC 6744 are not tightly wound. They are vast, loose, and incredibly diffuse, stretching out into the galactic hinterlands with a graceful, almost lazy sweep. This creates a galaxy of immense physical size but lower overall density, a more spread-out version of the familiar cosmic pinwheel. Adding to this mirror image quality is its own small companion, a dwarf irregular galaxy catalogued as NGC 6744A. This tiny, ragged satellite orbits the giant spiral much like the Magellanic Clouds orbit the Milky Way, a testament to the hierarchical nature of cosmic structure where large galaxies govern smaller entourages. For astronomers, this system is a priceless laboratory. By studying this bigger, older sibling, we gain insights into the potential long-term fate and dynamic history of our own galactic home. The vast, extended halo of NGC 6744, for instance, is a region of sparsely scattered stars and ancient globular clusters that stretches far beyond the bright disk. Our own Milky Way possesses a similar, though less pronounced, stellar halo. The nature of this halo, its shape, the motions of its stars, and its chemical composition is a fossil record of the galaxy's growth. It tells the story of ancient mergers of smaller galaxies consumed and digested billions of years ago, their stars scattered into this diffuse cloud. By meticulously mapping the halo of NGC 6744, scientists can work backwards to understand the assembly history of this spiral giant, which in turn provides a template for interpreting the more subtle clues within our own galaxy's halo. Furthermore, the loose winding of its arms suggests a different rotational dynamic and mass distribution, offering clues about how a galaxy's structure evolves over tens of billions of years. This celestial doppelganger, shining in the constellation Pavo, is more than just a beautiful spiral. It is a cosmic mirror held up to our own place in the universe, allowing us to see our home not from within, but as a complete and evolving island in the dark. But for all its majesty, the spiral twin NGC 6744 is a structure of light and life. The fate of a single star, however, can create a monument of breathtaking symmetry from its own death. NGC 3132, the Southern Ring Nebula, gleams in the constellation Vela like a cosmic smoke ring, a near-perfect sphere of glowing gas illuminated from within. This is a planetary nebula, the final, beautiful shroud cast off by a dying sun-like star. Its popular nickname, the Outburst Nebula, comes from the delicate, bubble-like lobes that appear to overlap, creating an intricate pattern reminiscent of a flower or a celestial mandala. At first glance, this luminous shell seems serene and symmetrical, a final, peaceful exhalation. Yet the truth at its heart is far more dynamic, and it hinges on a stellar secret. The brilliant blue-white star you see shining at the very center is not the primary culprit of this cosmic display. That star is a hot white dwarf, the exposed, searing core of the original star, and it provides the fierce ultraviolet radiation that makes the nebula glow. But it is not alone. Careful observations reveal a faint, reddish companion star orbiting very close to it, a cooler, older sun that was once the dominant partner in this binary system. This hidden star is the key to the nebula's beautiful shape. Astronomers believe that as the more massive of the two stars reached the end of its life and began to swell into a red giant, its outer atmosphere actually engulfed its smaller companion. The companion star, now orbiting inside the bloated giant's envelope, acted like a cosmic egg beater. Its gravitational pull churned the dying star's outer layers, funneling the ejected material not in a random sphere, but into a more focused bipolar outflow. Think of it as a stone whirling around inside a water balloon, creating two opposing jets as it spins. When the red giant's envelope was finally cast off entirely, it was this invisible gravitational dance that sculpted the gas into the intricate, double-lobed structure we see today. The brighter central star, the white dwarf, now lights up that pre-sculpted cavity, so the stunning symmetry of the Outburst Nebula is not a product of a solitary star's quiet death. It is a fossil of a gravitational tango, a lasting monument to the invisible influence of a dim companion whose gentle tug from within the chaos of stellar death guided the final breath into a perfect ring of light. The perfect symmetry of a planetary nebula is born from a hidden stellar dance, but entire galaxies can also be sculpted into rings by similar cosmic violence. NGC 7742 is a galaxy that wears its strange history like a luminous crown. From our vantage, it appears as a brilliant, compact core surrounded by a single, stunningly perfect ring of young blue stars and pink nebulae. This is not a typical barred spiral where a central bar funnels material inward. This galaxy has no bar at all. Its core is small and isolated, a bright knot of older stars that seems almost detached from the magnificent ring of star formation that encircles it. The ring itself is not a flat disk. It is slightly warped, giving the entire structure a subtle, three-dimensional quality, like a glowing cosmic hula hoop set askew in the void. How does a galaxy end up looking like this, with all its stellar birth concentrated in a single, distant loop and its center so quiet? The leading theory is a story of a precise and devastating impact. Astronomers suspect that billions of years ago, a smaller companion galaxy plunged almost directly through the heart of NGC 7742. This was not a glancing blow that created tidal tails, but a head-on collision, a cosmic bullseye. The gravitational shockwave from this event would have radiated outward from the center like a ripple in a pond. This powerful density wave swept through the galaxy's vast reservoir of gas and dust, compressing it violently as it traveled. By the time the wave reached a certain radius, it had gathered and squeezed enough material to trigger a firestorm of star formation, lighting up that precise circular band. The inner regions, having already been passed by the wave, were left relatively undisturbed, their gas either consumed or pushed outward, leaving the bright but quiescent core we see today. This makes NGC 7742 a fossil of a very specific kind of catastrophe. Its beautiful ring is not a permanent structure but a temporary blaze. The burst of star formation will eventually consume the available gas in the ring, leaving behind a population of aging stars. Over billions of years, the ring will fade, and the galaxy may settle into a more ordinary, if somewhat puffed up, shape. For now, it stands as a celestial bullseye, a near-perfect record of a direct hit that turned a spiral into a brilliant, star-forming circle in the sky. The serene symmetry of a ring galaxy is born from a single, precise impact, but other systems are shaped by a longer, more chaotic history of gravitational harassment. NGC 4631, the Whale Galaxy, swims through space as a magnificent, edge-on spiral, its profile a long, slender ellipse of dust and starlight that indeed resembles a cosmic leviathan breaching the void. Its most striking feature is not its shape but its atmosphere. Surrounding this stellar whale is an immense, faint, and incredibly turbulent halo of hydrogen gas, a seething ocean of raw material that extends hundreds of thousands of light-years beyond the galaxy's bright disk. This is no calm, static envelope. It is a roiling, disturbed sea, and the cause of the disturbance is swimming right beside it. Orbiting the whale is its small, peculiar companion, NGC 4627, a dwarf elliptical galaxy that looks more like a chaotic puff of stars than a structured island. This dwarf is not a peaceful neighbor. The gravitational tug of war between the massive spiral and its smaller companion has left both galaxies visibly scarred. The whale's disk is noticeably warped, bent out of its flat plane like a twisted vinyl record, a clear sign of ongoing gravitational stress. Streamers of hydrogen gas detected by radio telescopes can be seen being pulled away from the main galaxy, stretching toward the dwarf. This process, called tidal stripping, is like a cosmic riptide where the stronger gravity of the larger galaxy slowly tears material away from the weaker one. But here, the interaction may be more complex than a simple theft. The vast, extended halo of gas around the whale is so enormous and energetic that astronomers suspect it is not all native. Some of this material may be gas that was stripped from the dwarf companion, or from other, even smaller galaxies that passed by and were completely dismantled, their gaseous remains now added to the whale's expansive atmosphere. This creates a dynamic galactic ecosystem. The halo acts as a colossal reservoir of potential star-forming fuel, but it is a reservoir in constant flux. Gas may rain down from this halo onto the whale's disk, seeding future generations of stars, while simultaneous gravitational interactions with companions like NGC 4627 are siphoning other streams of gas away. It is a continuous cycle of accretion and loss, a delicate balance between gathering material and having it stolen. The Whale Galaxy, with its warped disk and gigantic, disturbed halo, is a living snapshot of a galaxy that does not exist in isolation. It is a dynamic entity, constantly reshaped by the gravitational pull of its entourage, its beautiful edge-on silhouette telling a story of companionship that is as disruptive as it is enduring. The serene, edge-on profile of a galaxy can be a beautiful mask hiding the true depth of its history. NGC 4565, known as the Needle Galaxy, is perhaps the most perfect example of this cosmic illusion. Seen from our vantage point, it is a breathtaking sliver of light, a razor-thin line of stars and dust set against the velvet black of space. Its beauty is legendary, a classic portrait of a spiral galaxy viewed perfectly from the side. The strangeness, however, lies in the details of that perfect line. Its central bulge is a subtle, golden yellow oval, and slicing across it is a dust lane of astonishing precision, a ruler-straight, dark band of cosmic soot that divides the galaxy's luminous halves with geometric perfection. This thin, serene disk suggests a galaxy living a quiet, orderly life, rotating peacefully in isolation. But when astronomers looked beyond the visible light, they uncovered a reality far grander and more violent than the needle's elegant profile implies. Surrounding this impossibly thin disk is a colossal spherical halo of dark matter and ancient stars, a structure that extends for hundreds of thousands of light years in all directions. This halo is populated by a vast retinue of globular clusters, dense balls of ancient stars that orbit the galaxy like a dispersed cloud of fireflies. The sheer size and richness of this halo is the shocking part. It is far more massive and extensive than the beautiful, thin disk of stars we can see, containing perhaps 10 times more mass in dark matter alone. This discovery transforms the story of NGC 4565. A halo of this magnitude is not built gently. It is the signature of a cannibalistic past. The serene needle we admire is likely the survivor of multiple violent mergers, a galactic predator that consumed smaller dwarf galaxies over billions of years. With each act of cannibalism, the victim galaxy's stars were stripped away and scattered into this immense spheroidal cloud, while its dense core, a globular cluster, was captured and added to the swirling halo. The dark matter that once belonged to those devoured galaxies now forms the invisible gravitational scaffold that holds this entire lopsided system together. The thin, pristine disk we see is therefore a latecomer, a structure that formed or survived within this chaotic halo, perhaps settling into its current perfect alignment only after the era of major mergers had passed. It is a galaxy of profound contradiction, a disk of serene order floating within a spherical testament to ancient violence, a needle threading the eye of a cosmic storm. The serene needle of a galaxy shows how order can emerge from a violent past, but the cosmos also weaves connections on a far grander scale. Far beyond any single galaxy, the true architecture of the universe becomes visible. In the faint constellation Pisces, the NGC 507 group offers a stunning example of this hidden framework. This is not a single object but a gathering of galaxies, a small cluster dominated by a true giant, the elliptical galaxy NGC 507. This massive sphere of ancient stars holds gravitational sway over its neighbors, including the smaller elliptical NGC 508. For decades, these appeared as separate islands of light, each with its own distinct identity. But when astronomers turned the X-ray vision of space telescopes like Chandra toward this region, they saw something that redefined the entire scene. The galaxies were not isolated at all. They were connected by a colossal, luminous filament of superheated gas. This bridge of million-degree plasma stretches across the space between NGC 507 and NGC 508, a continuous river of raw material glowing fiercely in X-ray light. It does not stop at the galaxies either. This gaseous structure extends far out into the intergalactic void, forming a faint web-like haze that permeates the entire group. This is not a chance arrangement, it is a direct glimpse of the cosmic web in action. The prevailing theory of cosmic structure suggests that the universe is built like a sponge, with galaxies forming at the dense intersections of vast, invisible filaments of dark matter. Ordinary matter, the gas that will eventually form stars, follows this dark scaffold. What we are seeing in the NGC 507 group is the luminous trace of that process. The hot gas is the baryonic matter that has been drawn along these dark matter highways, funneled by gravity into the densest regions. The filament between the two galaxies is a cosmic pipeline, a channel for ongoing mass transfer. Gas is likely still flowing along this bridge, feeding the supermassive black holes at the galaxy's cores and providing fuel for future, though limited, stellar birth. This continuous structure demonstrates that the cluster is not a static collection of objects, but a dynamic, evolving system. Material is still falling in from the cosmic web, drawn toward the gravitational well of the dominant NGC 507, the cluster's central anchor. This inflow of gas can regulate the cluster's temperature and influence the growth of its member galaxies. The X-ray filament is therefore more than a beautiful bridge, it is a snapshot of construction. It shows us the universe in the act of building a galaxy cluster, using rivers of invisible dark matter to channel fiery gas into the waiting pools of gravity, connecting isolated islands into a single, breathing cosmic continent. This galactic architecture is built on flows of material and momentum, but sometimes the universe introduces a contradictory current. NGC 7479 is a barred spiral that seems to be fighting itself, a cosmic contradiction spinning in the void. At first glance, it is a textbook example of its kind, a bright, elongated central bar of stars from which two graceful spiral arms emerge, curving outward into the darkness. But a deeper look reveals a profound and unsettling twist. The spiral arms themselves are not flowing smoothly from the ends of the bar in a continuous motion. Instead, they are kinked and bent, appearing to swirl in the opposite direction to the galaxy's overall rotation. It is as if the galaxy's heart is spinning one way, while its limbs are trying to wind themselves up in reverse. This bizarre configuration, where the outer spiral structure seems to rotate backwards relative to the inner bar and disk, is one of the rarest and most dynamically puzzling sights in the cosmos. A galaxy is not a solid object. It is a vast collection of stars, gas, and dark matter all orbiting a common center of gravity. For such a clear misalignment to exist, something must have violently disrupted the galaxy's original unified spin. The leading explanation is a story of gravitational theft and introduced chaos. Astronomers believe that, in the relatively recent past, NGC 7479 had a close encounter with a smaller, gas-rich companion galaxy. This was not necessarily a full merger, but a near-miss powerful enough to allow the larger spiral's immense gravity to strip away vast streams of gas and stars from the victim. This stolen material, however, came with its own inherent angular momentum. It was orbiting in a different direction, perhaps even backwards relative to NGC 7479's original spin. As this captured matter was pulled into the larger galaxy, it did not simply blend in. Instead, it settled into the outer regions, its opposing momentum warping the existing spiral structure. Think of it like pouring a thin stream of water into a spinning pot from the opposite side. The new fluid doesn't immediately match the rotation. It creates ripples and countercurrents. In galactic terms, this incoming torrent of backwards moving gas compressed existing material, triggering new star formation that literally wrote the contradictory motion into the galaxy's visible structure. The resulting spiral arms we see today are thus a fossil of that event, a luminous signature of stolen momentum. This makes NGC 7479 a unique natural laboratory. Its strange kinematics force astronomers to model galaxies not as isolated, pristine systems, but as dynamic entities constantly altered by their interactions. The galaxy's very shape is a permanent record of a past encounter, a beautiful and twisted reminder that in the cosmos, even something as fundamental as the direction of spin can be rewritten by a passing neighbor. These cosmic stories are not just isolated curiosities, but a collective testament to the universe's boundless creativity. From galactic cannibals swallowing their neighbors to dying stars blowing perfect holes in space, the NGC catalogue is a treasure trove of cosmic anomalies. We have seen 25 objects that challenge our understanding of gravity, stellar evolution, and galactic dynamics. Each one is a puzzle, a question written in starlight, gas, and shadow. The polar ring galaxy, with its perpendicular wheel, forces us to map invisible dark matter. The keyhole nebula's empty void reveals the sculpting power of infant stars. The backward spinning spiral tells a silent story of gravitational theft. These strange objects are the result of billions of years of cosmic collisions, stellar explosions, and the invisible influence of dark matter. They prove that the universe is far stranger than we often imagine, operating on scales and with forces that continually rewrite the rules. Every time we point a telescope at the sky, we are not just looking at pretty pictures. We are reading a history book written in physics, a narrative of creation and destruction that is still unfolding. Which NGC mystery fascinated you the most? Let us know in the comments below. Do not forget to hit that like button and subscribe for more deep dives into space's greatest mysteries.